All right, guys, we are going to go through some more examples of turning word equations into skeleton equations. Remember, word equations use words to describe what happens in chemical reactions, and skeleton equations use formulas to describe what happens in chemical reactions. If you can interpret word equations and skeleton equations, then you can understand reactions no matter how they're written. Okay, so we're going to go through 3 examples together, and we are going to take the word equation and turn it into a skeleton equation. So read number 1 with me. This is the first word equation. Number 1 says, solid magnesium and chlorine gas react to form solid magnesium chloride. We're going to go through the same process of taking the names that we see in the word equation, as well as the things like solid, gas, that kind of stuff, and we're going to put it into formulas. So you got to decide what your reactants are and what your products are. Okay, your reactants will always go on the left side of the arrow, and the products will go on the right side. Okay, if you just take it word by word, it makes it really easy to figure out how to write your equation. Okay, so we're going to look at our first substance, solid magnesium. It's our first reactant because it's going to come together and react with chlorine. So we're going to have magnesium and chlorine on the left side of the arrow, and then we're going to have magnesium chloride on the right side. So again, we're just going to take it step by step. Okay, first substance is solid magnesium. Okay, if you go and you find magnesium on the periodic table, it's number 11, and its symbol is Mg. So I'm going to write that down. Okay, Mg. Okay, if you like to cross things out, that lets you cross out magnesium. Now, what do we do with the solid? Okay, remember, you put a little s in parentheses and you put it behind the symbol. So we're going to put a little s in parentheses behind the Mg. So that stands for solid magnesium. I'm going to cross out my solid. So we have solid magnesium written down in our word equation. When we see the word and, okay, what do we think about? Plus sign. So when I write my plus sign, that stands for and. So I'm going to cross out my and. Okay, next substance, chlorine gas. Okay, chlorine, the symbol, number 17, is Cl. But do we leave it all by itself, just Cl? No, okay, because it's a diatomic. You should have like a diatomic alert, all right? It's not Cl because it's a diatomic. Di means 2, so diatomic means 2 atoms of chlorine. We put our little 2 down below. Okay, so that took care of chlorine. But what do we do with the gas? Okay, we put a little G behind. Okay, that little G takes care of our gas. All right, we've just written down our 2 reactants, solid magnesium and chlorine gas. Mg is the symbol for magnesium. Cl2 is the symbol for chlorine because it's a diatomic. All right, now when you see words like react to form, you need to think about an arrow. Okay, so I'm going to draw an arrow. That arrow indicates that a reaction is going to happen and we're going to form new products. So I'm going to cross out react to form because I've just written it down with my arrow. One more thing we got to write down. It's our product, solid magnesium chloride. So you're probably thinking, well, I know I'm going to have to put an S. Okay, I'm not going to put it in front. I'm going to put it behind. And I know I'm going to have to think about the formula for a compound because you have magnesium and chlorine together to form magnesium chloride. So think back to Unit 3 when you had to name and write formulas. Okay, it kind of sucked, but this is practice. Okay, you got to think, is this going to be ionic or covalent? Okay, magnesium is a metal. Chlorine is a nonmetal. Metal plus nonmetal equals ionic. When you write the formula for an ionic compound, you must crisscross the charges. Okay, so on scratch paper, or maybe in my head, I'm going to think, okay, well, Mg, I know he's going to come together with chlorine. I don't want to just write a formula MgCl because that's lazy, okay? You're not actually thinking about crisscrossing if you're doing that. Okay, you look on your periodic table. Mg lives in the second row, alkaline earth metal. All of those elements have a 2+ charge. So I write my little 2+ next to Mg. Okay, then I think, okay, well, chlorine, he's always a halogen. He's in the 1 negative box, so I put my 1 negative. So this, again, is scratch work. What do you do with these charges in an ionic compound? Okay, the answer is you crisscross them. So you're going to bring the 1 behind the Mg and the 2 behind the Cl. So you'll end up with MgCl2. Okay, that's going to be magnesium chloride. Now remember, this is scratch work. So I'm going to go back to my answer page. Okay, my answer page, and I'm going to write on my product side MgCl2. That stands for what? What, guys? What does that stand for? I know you're just yelling it out. MgCl2 stands for magnesium chloride. Okay, but I still need to put in my solid, so I put my S behind the MgCl2, and I'm done. Okay, now, you might be freaking out like some kids, like some students do, and you might, well, you actually might not be freaking out, okay, but you can see here that you have Mg on the left and Cl2 on the right, and then you have arrow MgCl2. We did not just squish these together to get MgCl2 over here. We took our charges and crisscrossed them. Okay, so this is magnesium plus chlorine equals MgCl2. Okay, we're going to move on to the next one. Number 2. I'm going to get this straight. Okay, the reaction of hydrogen gas and bromine gas yields hydrogen bromide gas. Now this one is worded differently than the first one, but you got to use your reading skills and figure it out. Okay, the reaction of hydrogen gas and bromine gas, that's telling you your 2 reactants. Yields is a fancy word for forms. Okay, and you can see that you yield or you form hydrogen bromide gas. Okay, so our first reactant is hydrogen. So this reaction of, it's just kind of helping us figure out how the reaction's going. We don't need to really describe this in our skeleton equation. Okay, the first thing that we need to think about is hydrogen gas. The symbol for hydrogen is H. Okay, so you might be like, okay, sweet, it's just H. I'm going to go with it, and I'm going to put my G for gas. Okay, if you did this, you're almost right. But hydrogen is a diatomic. You will start to memorize these. So if it's a diatomic, it needs a 2. So we've just done hydrogen gas. Okay, we have our and sign, so that means we need to have a plus sign. Okay. Bromine gas, the symbol for bromine is Br. And again, you're like, okay, I'm going to put my gas down, my little G. Okay, if you left it like this, you're almost right. But bromine is in that 7, okay, and he's also got a 2. Okay, so we've just done bromine gas. Now, when we see a word like yields, we need to think of an arrow. Okay, we got our product to do. Hydrogen bromide, you might already know this. Okay, it's covalent, but it kind of is like an ionic compound. So what you can do is go back to your scratch paper. Okay, the charge of hydrogen is 1+. The charge of bromine is 1 negative. When you crisscross those, you're just going to get HBr. So I'm going to put that on my product. Okay, that gives me hydrogen bromide. What do I do with my gas? Okay, I put a G. And now I'm done. So my final answer for this one, if I can get it straight for you, H2G plus Br2G arrow HBrG. Now this is one where sometimes students, they freak out and they're like, okay, well, Ms. Stroh, I get that it's H2, I get that it's Br2, but why don't I get my product as H2Br2 like this? Okay, so some students will think, Ms. Stroh, why isn't it like this? Like if I just put together H2 and Br2, I should get H2Br2. But that's not right. That's just squishing. So you don't want to just squish. The reason we got HBr right here, what I'm pointing to, is from the charges 1 and 1. So this is wrong. The H2Br2 and HBr is correct. Okay, this last one is kind of a Mac Daddy, but you just got to take it step by step. Okay, it says, let me get it for you. Aqueous sodium hydroxide reacts with aqueous hydrogen chloride to produce aqueous sodium chloride and liquid dihydrogen monoxide. There are a lot of words in this little sentence, but you just got to take it step by step. Aqueous is a term that means dissolved in water. So think of the Spanish word for water, aqua or agua. Okay, aqueous, agua, they're kind of related. So aqueous is just a phase notation, kind of like the G and the S. Okay, and its symbol is AQ. Okay, so this we're just going to take it word by word. Sodium hydroxide, it is not an element, it's a compound. Okay, so if you look on your periodic table, you'll find sodium, Na, but you will not find hydroxide. Okay, hydroxide is a polyatomic ion that can be found on the back of the periodic table. Okay, if it's a polyatomic ion, you have to crisscross. Okay, so what we're going to do is take out our scratch paper again. Okay, we're working with sodium hydroxide. Okay, so what I'm going to do is write that on here. Okay, so this is old stuff. Okay, sodium hydroxide. Okay, Na is sodium, and it's 1 plus. OH, guys, it's on the back of your periodic table. That's hydroxide. It's 1 negative. When you crisscross those, you're going to get NaOH. Okay? Sodium hydroxide is actually a really strong base, and it can slime your skin off, so you got to be really careful with it. Okay, so when we go back to our answer page, it's not just sodium hydroxide, it's aqueous sodium hydroxide. So what we're going to do is we're going to write NaOH, that's our sodium hydroxide, and then we're going to put an AQ behind it, and that stands for aqueous. Okay? When we see these words, reacts with, okay, that's kind of like an and. Okay, so that's an and sign, that's a plus. Okay, we have another aqueous substance, hydrogen chloride. Okay, hydrogen chloride is very similar to hydrogen bromide. Okay, so we go back to our scratch paper. Okay, look up here when we did hydrogen and bromine. Same thing for hydrogen chloride. Okay, it's just H1Cl1. When you crisscross those, you're just going to get HCl. Okay, this is also called hydrochloric acid. This is the stuff that's in your stomach. So this is a really strong acid, and this can actually burn your skin off. Okay, so what we have going on in this reaction, guys, we have a really strong base and a really strong acid, and what they're going to do is create something that's not too dangerous. We'll learn more about acids and bases later. Okay, so we're going to go back to our answer page. Okay, for hydrogen chloride, we just did it. It should be HCl. And what form is it in? What phase? Okay, it's aqueous, so we put an AQ. Okay. We've done aqueous sodium hydroxide reacting with aqueous hydrogen chloride. Okay, see the next words, to produce. That should indicate an arrow. Okay, 2 more products. Aqueous sodium chloride. And think about this, guys. Sodium chloride, table salt. You should know the formula for this by now. If you don't know the formula, okay, all you do is go to your scratch work. Sodium is Na. Chlorine is Cl. Think about their charges, 1 and 1, 1 plus, 1 negative. You crisscross them, you just get NaCl, table salt. Okay? Now, we've just done sodium chloride. Sorry, this is so not high tech. Okay, we've just done sodium chloride, but it's aqueous, so we put the AQ. Now, I'm running out of space on my paper. If you do that, that's okay. Just go down to the next line. Ideally, you get it all on one line, but sometimes it doesn't happen that way. So what I have here is NaCl, AQ. Now we have an and sign, so I'm going to put a plus. Dihydrogen monoxide. Liquid dihydrogen monoxide. Covalent. Di means 2, so dihydrogen means H2. Mono means 1, monoxide means 1 oxygen, so O with the 1, put a little L behind it, and you're done. Okay, so now we have this big long wordy thing, aqueous sodium hydroxide, okay, which is represented right here, reacts with aqueous hydrogen chloride right here. to produce, arrow, aqueous sodium chloride, and that's NaClAq. I know it's hard to read, plus liquid dihydrogen monoxide. Okay, we are done. All right.